Hello, ladies and gentlemen. We are going to take a look at function operations and compositions today. So we are going to go ahead and do some actual math here with these functions and perform adding, subtracting, multiplying, as well as compositions, which means plugging one function into the other. So all of these expressions that we're going to be working with today are functions. They meet that definition, and we're going to just do some math and operations with them. So for this, you're going to need your notes. A calculator would be nice, as well as something to write with. So at the end of the lesson today, you should be saying, you know what, I can perform function operations, I can add, subtract, multiply functions, and I can also perform compositions. Here is a box with 4 functions in it. I would like you to write this in your notes. These 4 functions we're going to use repeatedly over and over again in all of our examples today. So that's why I put a box around it. They're going to appear on every slide, but you only need to write it one time. So writing those 4 functions, you can see we have an f of x, we have a g of x, we have an h of x, and we have a j of x. Now remember, those are just their names, and now the math or the whole adding, subtracting part comes in. We're going to actually do something with these functions. So like this first example says, we're going to take the g of x function and add the h of x function to it. So if we write down what the g of x function is in our list up there, it's x squared plus 4x minus 3. That's our whole g of x function, and we are going to add to it the h of x, 4x squared minus 2x. And we need to figure out what this is when we were to simplify everything. You learned about this in Algebra 1. Simplifying means combining like terms. Here in our case, we're adding. So 1x squared over here will get added to 4x squared right here, making 5x squared total. 5x squared. Now let's look at our x's. Positive 4x plus a negative 2x makes 2x's, so plus 2x. And then just I have 1 minus 3 or negative 3 right here. I don't have any constant values over here, so I'll just leave it as a minus 3. So g of x plus h of x equals this new expression here, 5x squared plus 2x minus 3. So we combine 2 functions here to make a new one. Let's look at our second example here. Notice that there's a 2 in front of f of x. That means we're supposed to take 2 times f of x and then subtract the g of x function from that. So let's start by thinking about that 2 times the f of x. What is the f of x function in our list? It's negative 2x. And then we'll go ahead and write subtract sign. And then the g of x function is x squared plus 4x minus 3. So now, remember, I'm putting parentheses around my functions here when I plug them in. That's because it'll help remind me when I need to distribute or things later on. Notice that I have a 2 that needs to be multiplied by a negative 2x. That's not negative 2 plus x, but just negative 2x. So if I do that, I get negative 4x. And then I need to subtract this whole function from that. Now remember, when you subtract, I'm hoping that you learned subtraction is the same thing as adding the opposite. So what we would do here is change that minus to a plus and distribute a negative sign to all of these terms in here. So we'd have negative x squared, negative 4x, positive 3x. And then I'm going to drop down that negative 4x. And now we look through our list and make sure we have these like terms. I do see an x squared. X squareds always come first here. They have the highest power. So I have one negative x squared. The x's would come next. I have a negative 4x here and another negative 4x here. When I'm adding here, guys, I'd say negative 4x and another negative 4x makes negative 8x. And just 1 plus 3 here. So my new expression turns into negative x squared minus 8x plus 3. So let's continue on with a couple more examples. We have 7 total today. We're on number 3 and 4 here. Same list of functions. Now we need to take j of x times h of x. So I'm just going to write what j of x is, x minus 5. And again, I always put them in parentheses. And then times h of x. You can write the little dot, or a lot of times in math we don't. 4x squared minus 2x. Now remember, in Algebra 1, you would take these and you would distribute these. Okay, double distribute, sometimes you call it FOIL, depending on your Algebra 1 experience. X times a 4x squared here gives me 4x to the third. And now we're going to take an x times the negative 2x. That's negative 2x squared. And now we need to take that negative 5 times the 4x squared, negative 20x squared. And the negative 5 times negative 2x is positive 10x. So looking through my list of terms, let's see if we can combine anybody. These are both x squareds. So I'd have 4x to the third. He's the highest power. He comes first. Negative 2x squared minus 20 more would be negative 22x squared, and then plus 10x. So j of x times h of x gave me this new function. Let's do the same thing with f of x times g of x. F of x is negative 2x. G of x is x squared plus 4x minus 3. Now be careful on this one. Sometimes people think this is another one of those double distribute ideas. Negative 2x is one term. It does not have an add or subtract in between them. So I take them together times each piece of my second function here. So negative 2x times x squared is negative 2x to the third. Negative 2x times 4x is negative 8x squared. And negative 2x times the negative 3 in the back is positive 6x. So my new expression here for f of x times g of x gives me that new function. Okay, a couple more. Let's remember what h of negative 2 means. So this is a situation where I'm not multiplying h times negative 2. If I needed to do that, it would look like this. Times h of x, negative 2 times h of x. This one is asking me to do that whole substitution, okay? So it says take the h function and plug negative 2 into it. So where the h is this 4x squared minus 2x, everywhere there's an x, I need to replace it with a negative 2. So this x is going to become negative 2. And then this x is going to become negative 2. And now if we go ahead and calculate this, remember we start with parentheses, then exponents, then multiplying and dividing. That means I shouldn't multiply 4 times negative 2 first. That's not right. I start with these exponents here. I need to take negative 2 squared first. So 4 times negative 2 squared would be another 4. And then minus, and I'm just going to drop the rest down. Now I can do that multiplication. 4 times 4 is 16. This is a negative 2 times a negative 2 here. That's a positive 4. 16 times 4, or 16 plus 4 is 20. So h, when I plug in negative 2, becomes 20. Now remember, this whole start tells me what function to start with and what I need to plug into it. So when we look at this second example, this is called a composition. Because it's not adding, it's not multiplying, it's not plugging in a value, it's not subtraction, it's called a composition. We are going to compose these functions because we're going to plug one into the other. We read this one the same way. Start with the j function, write that first, and instead of plugging a number into it, like the negative 2 on the other example, we're going to plug in an entire function into it. So the first thing I always do is start at the beginning, write that j function. It's x minus 5. That's what it says in my list. And where the x is located in this function, I'm going to kind of put a box around him. I'm going to replace that x with this entire g function. So that is the x squared plus 4x minus 3. So where that x is going to become x squared plus 4x minus 3. And then I'd still have my little minus 5 after it. So if I were going to simplify this, I'd have x squared plus 4x minus 8. Okay, let's do one more example like that because compositions can be rather tricky. Let's start with the g function and plug the f function into it. This one's going to be a little complicated, I'll forewarn you, but we can do this. So first, the g function, we write that first. X squared plus 4x minus 3. Now everywhere there's an x, I'm going to replace it with the entire f function, so the entire f equation. So there's an x here and there's an x here, and they're both going to be replaced with the f function. So it's going to become negative 2x, because that's the f function, squared, plus 4, and then negative 2x goes where that x was as well, and then the minus 3. And now I'll go ahead and calculate this or figure this out. Be careful here, negative 2x squared, guys, means it's negative 2x times another negative 2x. So negative 2 times negative 2 would be positive 4. X times x makes an x squared. That's what that term becomes when you square it. Now the other term over here, I'm going to leave my plus sign there. 4 times negative 2x is negative 8x. And then I still have the minus 3. So simplest way to write it, 4x squared minus 8x, and then again minus that 3. So the g function with the f function plugged into it works out to be this new function. Okay, so we're just going to practice with some of those operations. It takes some getting used to reading that notation. I know you have the Algebra 1 background to work out and simplify these. It just takes a little practice. I want to thank you for taking good notes today, and I'll see you when I see you.